Welcome to This Explainer. Today we're taking some pretty dense microeconomic theories and translating them into a completely intuitive guide on how businesses optimize their operations. If you've ever wondered how successful companies figure out exactly how many people to hire and machines to buy without wasting a single dollar, well, you are definitely in the right place. We're going to start with a really fascinating mystery. Why is it that simply throwing more humans at a problem can actually hurt your total output? It seems completely counterintuitive, doesn't it? I mean, we naturally assume that more hands on deck guarantees more results. But as you'll see, that assumption is a pretty dangerous trap for any business builder. Here's our roadmap for today. First, the production function. Second, the short-run reality. Third, the law of diminishing returns. Fourth, the long-run flexibility. And finally, number 5, the Cobb-Douglas model. Let's kick things off with section 1, the production function. The recipe for goods. Okay, so every great business starts with a recipe for creating goods. Economists call this the production function. It basically maps out the technical relationship between your physical inputs and your physical outputs. You can think of this formula as your company's DNA. It represents the exact combination of human effort, which is your labor, and machinery, your capital, required to produce your product given your current technology. Moving right along to section 2, the short-run reality, fixed constraints. Now let's drop into the immediate reality every new business owner faces. In the short run, your output can only be increased using variable inputs, purely because your fixed inputs remain strictly constant. What does that mean in plain English? Well, it means you can easily hire more cooks for your kitchen today, but you're completely stuck with the single oven you already own. You can't just instantly manifest a second oven or magically expand your square footage. Those things take time. Which leads us perfectly into section 3, diminishing returns. The bottleneck. Because of those short-run constraints, we hit a major bottleneck governed by a foundational rule, the law of diminishing returns. This states that adding an additional variable factor of production will eventually result in smaller and smaller increases in your output. If you just keep cramming new cooks into that tiny fixed kitchen, eventually they're going to start bumping into each other, dropping plates, and actually slowing everything down. Your return on every single new hire shrinks. So the absolutely crucial point here is understanding these 3 stages of production. In stage I, everything is highly efficient. Your total product is increasing rapidly. In stage 2, your total product is still growing, but now it's at a slower, decreasing rate. But look closely at stage 3. This is where the magic dies. This is where hiring that next worker actually causes negative marginal returns and makes your total production drop. You're literally paying more wages to produce fewer goods. And mathematically, this creates a literal cliff where a business goes from optimizing its workforce to actively sabotaging its own efficiency. The total product curve peaks at the exact moment the marginal product curve hits 0. The second that marginal line dips below the axis into negative territory, production plummets. It is, without a doubt, the ultimate business nightmare. But eventually, time passes, leases expire, and we enter section 4, long-run flexibility. Inputs are variable. Welcome to the long run, where all inputs are finally variable. You can go out and buy that second oven, but now you have to carefully balance your output goals against your absolute budget realities. We track this using 2 tools, the Isoquant Curve, which means equal quantity, and the Isocost Curve, which means equal price. The Isoquant shows all the combinations of labor and capital that yield the exact same output. The Isocost, on the other hand, shows combinations that cost the exact same total amount. Now, when you find that exact point of tangency, where the Isoquant curve perfectly grazes the Isocost line, you've found the holy grail of cost minimization. At this very specific point, a metric called the marginal rate of technical substitution perfectly equals your wage-to-rent ratio. Simply put, this represents the precise moment your business is producing your target number of goods for the absolute lowest possible price. So how do we calculate this? Let's look at section 5, the Cobb-Douglas model, ultimate cheat code. To precisely measure this balancing act, economists in 1927 developed what I like to call the ultimate business cheat code. Now, don't let the math scare you off. This is really just a clear, structured way to see exactly how much extra bang for your buck you get when you swap a machine for a worker. The formula multiplies your technology, labor, and capital together. But the real stars of the show here are the little exponents, alpha and beta. They measure elasticity, which is exactly how responsive your output is to changes in labor and capital. By simply adding those two tiny exponents together, you determine your returns to scale. It instantly predicts if doubling your budget will scale your business efficiently. If alpha plus beta exactly equals 1, you get constant returns, meaning doubling inputs exactly doubles your outputs. If it's greater than 1, you have increasing returns, so doubling your budget will actually more than double your profits. And if it's less than 1, well, you're looking at diminishing results. What's really cool is that the ratio of alpha to beta reveals your company's true DNA. A higher ratio means you are highly responsive to human effort, making you labor-intensive. Conversely, a lower ratio means your real operational power relies on heavy machinery and infrastructure, so you are capital-intensive. This beautiful little detail tells you exactly where to invest your next dollar for the maximum possible impact. So, here is the big question for you. Think about how you would design your own optimal recipe for success, given everything we've discovered. If you were starting a company tomorrow, would you build a massive, heavily automated, capital-intensive factory or a dynamic, labor-intensive team? I hope this explainer has given you the economic tools to build it perfectly, avoid that deadly trap of diminishing returns, and hit your sweet spot of ultimate cost minimization. Keep analyzing, keep optimizing, and I'll catch you in the next explainer.